Welcome to The Explainer. Today, we're tackling a truly fascinating anatomical accounting mystery. We are going to track a piece of everyday food right through the human body with absolute forensic precision. We're literally going to follow every single gram to find out exactly where it ends up. Okay, let's dive into this. So, here's the core of our mystery today. Imagine you eat exactly 113.4 grams of a raw carrot. That works out to precisely 4 ounces. You chew it up, you swallow it, and boom, you've just put a relatively heavy, solid chunk of vegetable into your body. Now, instinctively, we tend to assume that what goes in as a solid mass must eventually come out as an equal amount of solid waste, right? Well, prepare to have that common assumption completely dismantled as we track these grams. Now, what's really interesting about this side is the massive plot twist hiding right inside that very solid-looking raw carrot. Just look at this component breakdown. Out of those 113.4 grams you just chewed up, a staggering 100 grams is just water. The rest is incredibly small. We're talking a tiny sliver of usable carbohydrates at about 7.5 grams, 3.2 grams of dietary fiber, just 1.1 grams of protein, and a minuscule fraction of fat and minerals making up that final 1.6 grams. You probably thought you were eating a dense solid, but structurally, you're essentially eating a very crunchy glass of water. Let's audit that 100 grams of water first. Once absorbed, it joins the tens of kilograms of water already sloshing around inside you. I mean, your kidneys have absolutely no idea if this water came from a carrot or a glass of tap water. It mixes completely indiscriminately and eventually exits through urine, breath, sweat, and stool. Scientifically speaking, we just can't tag and track carrot water to the exit door. But what about the solid, dry stuff? Let's walk chronologically through the digestive journey. In step 1, your mouth chewing physically breaks the carrot into smaller particles, while your saliva adds even more water. Moving down to step 2, the stomach. It gets mixed with stomach acid and digestive secretions. It softens up, sure, but it's really just a holding tank here. Absorption hasn't quite started yet. Step 3 is where the magic happens, the small intestine. This is where the vast majority of those usable, dry nutrients are absorbed directly into your bloodstream. So by the time the remains hit step 4, the large intestine, practically all the usable fuel has been completely stripped away. Consider this our forensic accounting ledger for those absorbed nutrients. Let's look at the fate of these tiny amounts. We've got about 5.4 grams of natural sugars. Now, these don't just sit in your body as permanent sugar. They enter the bloodstream and are either burned immediately for energy or temporarily stored as glycogen. If your overall energy is balanced, it's not turning into permanent body fat. We also have 1.1 grams of protein, which is broken down into amino acids to be used or recycled by your tissues. And that microscopic 0.3 grams of fat, it's absorbed and oxidized or temporarily incorporated into your cells. The body uses these tiny amounts based on what it needs right in that exact moment, rather than just packing it all away. Let's move to and see how this builds our physiological mystery. Remember step 4, the large intestine? Well, because human digestive enzymes simply cannot completely digest dietary fiber, those 3.2 grams of carrot fiber travel all the way down to the colon totally intact. But they don't just sit there waiting for the exit. Your intestinal bacteria get to work and ferment a portion of this fiber, breaking it down even further into short-chain fatty acids and gases. So let's anchor ourselves back to the starting line for a second. We have to follow the grams to close this audit. Remember, we swallowed exactly 113.4 grams of solid raw material at the very beginning of this process. We know 100 grams of that was water that got absorbed. The usable carbs, the proteins, and the fats were all absorbed into the body, and the fiber was partially fermented by bacteria. Which brings us to an incredibly shocking contrast. Out of that entire 113.4 gram chunk of raw carrot, do you know how much of the original carrot material actually survives to become dry fecal matter? Just 1 to 2 grams. That's it. Sure, your actual stool associated with that meal weighs more because it contains water, gut bacteria, shed cells, and other things. But the original carrot solids directly surviving into your feces, it is barely 1 to 2 grams. And here is where our accounting audit gets really intense. We have an undeniable discrepancy here. If you subtract the 100 grams of water and you subtract the 1 to 2 grams of fiber that become poop, well, we are still missing several grams of dry, solid mass from that carrot. It didn't turn into permanent body fat. It didn't end up in the toilet bowl. So where exactly did the rest of that solid mass go? And this brilliantly illustrates one of the most mind-blowing physiological twists in the human body. Look closely at this equation for metabolism. When your body burns glucose, which came directly from the carrot's carbohydrates, it combines that glucose with oxygen. The result? It produces the energy you need to live, sure, but the physical byproducts are water and carbon dioxide. When you metabolize those dry nutrients, you are quite literally converting solid carbon atoms into a gas. Let's tally up the actual exit routes for our missing mass. We know excess nitrogen from the carrot's protein is converted largely into urea and leaves through your urine. The water leaves through urine and sweat. But here is the invisible exit that is so easy to overlook. A massive fraction of your meal's dry matter, the carbon from the burned carbohydrates, the oxidized fat, the fermented fiber, literally disappears into thin air. It leaves your body through your lungs. You actually breathe out the missing mass of your food as exhaled carbon dioxide. Crazy, right? So, the crucial point is this. Your food doesn't simply divide into what you temporarily keep and what you eventually flush. A meaningful, substantial percentage of the dry, solid matter you are eating right now is ultimately destined to be exhaled. Next time you sit down to eat a meal, ask yourself, how much of this solid food will eventually vanish into the air around me? It completely changes how you look at digestion. Thanks for joining me on this forensic audit today. I hope it leaves you breathing a little differently about your next meal.